Hello, everyone. Welcome back. So, today we are going to continue with our exponents laws, except today we're going to be talking about rational exponents specifically and what do they mean. So, what rational exponents are basically powers with a fraction because all of the powers previously have always been integers. So, plus 3, minus 5, blah, blah, stuff like that, or is maybe 0 even. But we have not done any with fractional exponents. And I'm going to talk today about how we need to interpret a fractional exponent. Okay, so a fractional exponent would look like this. We have y equals x to the power of m over n, for example. This is the same thing as x to the power of m to the nth root. So basically, it's like we have m over n, the flower pot, right? This is the metaphor people will use. This is our root. And then m is like our flower, right? Flower. Or power, rather, right? So we have our root in the bottom and our power on the top, essentially. So if that picture helps you, great. If not, that's okay too. But that's one way to look at it is we have our root on the bottom, our power on the top. And it does not matter, it will not make a difference whether we do the power first and then the root, or root and then the power, because they're essentially the same thing. If I give you, say, okay, let's take x squared and then let's square root it. Okay, well, we've got x again. Okay, well, assuming we're just taking the positive square root. Well, great, we did it. Let's say we take the square root first and then we square it. Well, we still have x. We still have the same thing. And so it doesn't matter which order we do it in terms of getting the answer correct. Often it is better, if possible, to take the root first just so you have smaller numbers, but it will work either way, and the calculator will not care. So let's go through some of these. The first one is 81 to the 1/4. Okay, so that means we have this is the same as the quarter root of 81 because our power is just the 1, so the power is just, the same. And 4 is, on the bottom, so that's our root. So what's the fourth root of 81? Well, that's going to be 3, right? Because 3 times 3 times 3 times 3 is 81. So 3 is our answer here. Let's try this next one. What is the third root of negative 64? Well, we know it's got to be something negative because only when we multiply a negative to itself 3 times can we get another negative. If we multiply a positive times positive times positive, right? If we multiply a positive to itself 3 times, then we're going to end up with something positive. So it must be negative is our first thing. And then what's the, what number would it be? Well, it would be 4, right? 4 times 4 times 4 gives us 64. So therefore, negative 4 times negative 4 times negative 4 gets us to 64. Now, what about this one here? 25 to the power of 3 over 2. This is the same as 25 cubed. Or rather 25, the square root of 25 cubed. Right? 3 is our power, 2 is our root, and it doesn't matter which order we do things in. Now, I'm going to take the root first before the power because it'll make my life easier. Okay, so let's do that. What's the square root of 25? Well, that's 5, if we're just assuming the positive. And then 5 to the power of 3 is 125. And voila, there's my answer. Then we have 16 to the power of 3 over 4. So that is the fourth root of 16 cubed. So what's the fourth root of 16? Well, that's 2. So that's the same as saying 2 to the power of 3. And 2 to the power of 3 is, of course, 8. So you can probably see, you probably noticed at this point, that it's just the same stuff over and over and over again, right? All this is just we put the whatever's on the denominator of our fraction that we're taking the exponent, that's our exponent fraction, and we are making it the root, and then we're taking whatever's on the top, whatever's in the numerator, and we're taking it to the power. And that's all we're doing, right? There's a clear pattern how we kind of did the exact same thing all throughout this entire page. Now there's a few more of these before we're through, and I will go through all of these in this video. There are only 4 of them. It would be kind of silly for me not to, but I do encourage you to pause the video and try to do as many of these as you can on your own, and then we'll move forward from there. Okay, so this first one has a negative. So the very first thing I'm going to do is I'm going to flip it. So 27 becomes 1 over 27 to the same power, just without the negative. My second step is I'm going to take the root. So this is going to be the cube root, 27, and all of this squared. Now, technically, we would need to take the cube root of 1 as well. However, since that's just 1, I ignored that fact. However, actually, I should write it in. I'll write it in just to show that, yes, we do need to take that root to both the numerator and the denominator. We can't just do it with 1. Now, that said, we're just going to get 1 on the top anyway, so it actually doesn't matter in this case. And then we're going to get on the bottom 3, right? 3 times 3 times 3 gives us 27. So now we have 1/3 squared, which is 1 over 9, and that's our answer. All right, let's try this one, negative 4 over 3, with 64 as our base. So I see a negative, so same thing as before, I'm going to flip it. So 1 over 64 to the power of 4 over 3. Well, that's the same as the cube root of 1 over the cube root of 64, and all of that to our power of 4. That's equal to 1/4 to the power of 4, because the cube root of 64 is 4, right? 4 times 4 times 4 is 64. And then 4 times 4 times 4 times 4. Well, let's see what's that, because we're going to have to take both of these numbers, 1 to the power of 4, which is clearly just 1, and then 4 to the power of 4, which is 256. So this is going to be 1 over 256. Awesome. All right. Let's move on to G. So G is also negative. Actually, all these are negatives. Perhaps before mentioning that you guys should try yourself, I should have gone through one of the negative ones just to give a kind of a different example and then said it. But oh well, that's okay. So this is also negative. So we're going to put 25 on the top and 16 on the bottom. Then we're going to square root both and take to the power of 3. So that's going to end up being 5 over 4 to the power of 3, which is equal to 125 over 64. And that's our final answer. Okay, what about H? So H, again, we have to flip it. So we have 8 over 27 to the power of 2/3. Then we'll take the cube root of 8 and the cube root of 27 and square. Then we will say, well, that's 2 over 3 squared, which is 4 over 9, and that's our final answer. And all right, and that's everything for today. Next day, we will talk about the transformations of exponential functions, which is actually very similar to transformations of other types of functions. So if that's something you're familiar with, it will not be so bad. If you are familiar with it, if you're not familiar with it, then it may be more of a new topic to put more time into, but absolutely it's something where you can get as well. All right, well, that is everything for today, though, and we will see you next time. Bye, everyone.